Okay, so in this video, I'm going to go ahead and walk through the worksheets, the 4.1, 4.2 worksheet. Remember, these topics are the ones that match the topics for each unit. So if you're trying to figure out how do I do this, it's on that list, okay? Some of these problems I'm going to just show you how to do or just talk you through what I did. And then others I'm actually going to work for you. I actually have a clean copy of the exact same worksheet here, and I'll just work for you. I may even work it a slightly different way so that you can have more than one options to do it. Okay, so let's start with number 1, converting this degree to degrees minutes second. I'm going to go ahead and just redo all of these. So here I'm going to start with the 131.946. I'm putting that in the calculator. Make sure you're in degree mode. Go ahead and press this button right here, and then remember, just go back an arrow so you can get degrees minutes seconds. I'm going to press enter. You get the exact same number. Now, you get the exact same thing that I have here. So use your calculator. Make sure you're in degree mode. For this one here, you're going to do the opposite. You're going to type in each individual number. Let me scroll out just. Okay, so I'm going to go ahead and do 2 degrees. So 2 degrees, 54 minutes, and 26 seconds. One of the things that you have to keep in mind is if you're not given any minutes, you still need to put the minute sign. Just make sure to put a 0. Okay, if you don't do that, your calculator won't work correctly. Again, make sure you're in degree mode. When you press enter, you're going to get the exact same number. Okay, here it says round to the thousand, so you're doing 3 decimal places. Since this is a 2, this stays at a 7. Right? Use calculator degree mode if you're using this calculator. Okay. I'm going to go ahead and do this one where I'm converting this radians to degrees. Make sure you're in parentheses. Go -11 pi divided by 6. So in this case, whenever you're converting, you definitely want to put the pi in. Okay. You now need to tell the calculator, hey, this is a radian measure and I want degrees. So I'm going to go to this button again and tell it it's radians. Okay. Press enter and then enter again, -300 degrees, which is here. All right. Here you're going to do the exact same thing. It's asking you to round to the nearest hundredths. So I'm going to go ahead and I'm just going to go actually scroll up and then just replace these numbers with a 4 and delete the others unnecessary numbers. 4 pi over 17. I'm going to insert another number, 7, and then I'm going to press enter, and there's my 42.35. This 2 makes this 5 stay the same, okay? And I also put that note here. This is using the calculator. All right, now this problem, it says sketch in standard form. So remember, in standard form, if this is a negative, you always have to go down, okay? If this was a positive, then you would go up, and you would land actually in quadrant 3 if this was a positive value. So make sure that when you're doing these, that you start where you're at. If it's negative, you go down. If it's positive, you go up, and then that many degrees that you need. Okay, so this one is a little bit harder to actually do since we're using it on the paper. Okay, for the next one, coterminal angles. So remember, coterminal angles mean the same angle, they're just in different forms. So it's asking us to find an angle between 0 and 2 pi. Remember, I call that a standard angle that is coterminal with a -7 pi. So as you can see, all I'm doing is adding 2 pi until I get a number that is between 0 and 2. And I don't get it until this becomes positive. So 1 pi is between 0 pi's and 2 pi's. So this is going to be our answer. In this case here, it's asking again for a standard angle that is coterminal with 990. Give the exact answer. So again, now that it's higher, I'm going to actually be subtracting 360 degrees, or 1 entire rotation, until I get a number between 0 and 360. Okay, so number 1 says a circle has a radius of 19 meters. Find the radian measure of the central angle theta that intercepts with the arc of the length 18. Don't round any computations, but you do round your final answers to the nearest tenth. Using your unit circle, or your reference sheet, you're going to get the equation S equals theta r. Substitute your S, substitute your r. Theta is the one that's unknown. Now, in this particular case, because we're solving for theta, the calculations will automatically be in radians because your formula is supposed to be in radians. Okay, so all you're going to do is solve for theta, divide by 19 on both sides, and then you get your answer. Round to the nearest tenth place, which is 1 decimal. Since this is a 4, you're going to keep 9 the same. There are no units here because this is automatically going to be in radians. Okay. Next problem. A circle has an arc that measures 11 feet and it's intercepted by a centric angle of 73 degrees. Find the radius r of the circle. Okay, again, do not round any intermediate computations, but your final answer has to be rounded to the nearest tenth. So I'm going to say a circular arc, that's S, is equal to 11 feet. Your angle is 73 degrees. You need to change this to a radian, or you can use the calculator in radian mode, but specify that your 73 is in degrees. Okay, I'm going to go ahead and change that first over to radians. Okay, there we go. And then now I'm going to plug it in and solve for r. So here it's going to be 11 divided by 73 degrees. Press enter and I get 8.6. That 3 makes the 6 stay the same. And then don't forget your units. Even though there's no units down here because we're technically in radian, because I put it in radian mode, the feet has to carry over. Okay, so there's your answer. This is going to be a better way to do it than doing it by hand, just because if you round it like I did over here, you have to use the exact value and not the rounded value. Okay, the next problem is this one. Okay, it says a circle has a radius of 5.5 meters. The sector of the circle has a centric angle of 0.9. So here it's already in 0.9 radians. Find the area of the sector. Do not round the intermediate computations, but you round your final answers to the nearest tenth. Again, use your formula sheet. Here is the area of a sector. And then you're going to plug in the values that you got. Your 5.5 meters is your radius, and your 0.9 radians is here. So all I did was substitute your r, don't forget to square it, and your theta. Plug it into the calculator, and you got it. Make sure you're on radian mode, okay? So that's important. All right? It's good not only for... it's good practice, it's a really good habit as well. Because sometimes it's not going to make a difference, but the times that it does, you want to make sure you're on the right mode. Okay, number 2. The area of a sector with a centric angle of, again in radians, and it gives us the area. So anytime you have a unit that is squared, then you're talking about area. Find the radius of the circle. Again, do not round until your final answer, and then you go over only to the 10th place. So here I'm putting in all my values. I'm using the exact same equation. And now I'm going to plug in A, which is the 23 millimeter square here. R is what we're trying to solve. Theta is 5 pi over 6. What I did here was I multiplied by 2 to cancel the 2's out, and I flipped this angle. So everything cancels out as well. Now if you do that to this side, you have to do it to this side too. So you'll see the 2, 6, and divided by 5 pi over here like you do over here. Okay. Now what I do is just plug all of this into the calculator. Now keep in mind this square does not apply to the 23. This is part of the units. So all you're doing is doing 6 times 2 times 23 divided by 5 pi. If you put this in the calculator, make sure you put 5 pi in parentheses. Let me show you. Okay, so here I'm going to do 2 times 6 times 23 divided by 5 pi. Okay, if you don't put that 5 pi there, there's your answer. Okay, and remember that's r squared, so then you take the square root of that. If you don't put this in here, the order of operation is going to be incorrect. Let me show you what I mean. I'm going to take away the parentheses and press enter. I don't get the exact same number. I had 17.56 and now I have 173. Those are completely different. This is the correct answer. So using the order of operations is going to be important. Then you're going to take second square root, which is right here, okay, and then do second answer. Second answer will make sure that you put in the previous answer in there, and then now you can round it when you're doing this part. I got 4.19 and then rounded to 1 decimal places. You get 4.2 millimeters. Okay, so in this next part here, this is where the problems begin. I'm going to go ahead and read the question. Here are the formulas that I got from the formula sheet. So that's where I'm using right now. And I have all of them. So it says Pluto has a radius of 700 miles. I have 700 miles here as my R. And the planet rotates on its axis where a point on the equator travels this many miles per year. So the miles per year tell me that this is distance per time. This is a distance. Remember, S is a distance on the circle and T is time. So I can say that this value here is a velocity, distance per time. So I'm going to assign that the value V. Okay, so let's go ahead and look at the first problem. It says find the angular speed of the point. Well, if we know the velocity and we know the radius, we can find the angular speed by using this formula. So I use V equals R times angular speed. Now, if I'm solving for angular speed, I'm going to divide by R on both sides. So that's where I get this, this formula here. Substitute the value you got for velocity. This is miles per year. And then you're going to divide by your radius, which is 700 miles. Notice your miles will cancel out. So when I do this calculation in the calculator, I'm just rounding to the nearest whole number. So I'm going to get 382 radians per year. You don't need to put radians, but the only reason I did is because remember, when you're talking about angular speed, it's radians per unit of time. So if you don't have radians up here, that's okay. The second part says find the number of rotations it makes. So if you remember when we talked about the rotations, now we're going from angle in radians to a certain time to how many times it actually completes a rotation. That's what we're looking for when we're looking at rotations per year. So we're going to start with our angular speed, and remember 1 rotation is 2 pi. Now because this is radians, we can put radians here and they will cancel out. So then you're left with rotations per year. So if you just did this in the calculator, again, make sure to include the 2 pi in parentheses. You should get approximately 61 rotations per year. Okay, let's go on to the next problem. Okay, for the next problem, I'm going to go ahead and do this, not using the stuff that I wrote out. This is, I think, pretty self-explanatory, but I'm going to go ahead and create a new one. So here's my new sheet. So let's go ahead and read the question. It says a cyclist is riding a bicycle whose wheels have a radius of 12. So let's start with that. Radius is 12 inches. Okay. Suppose the wheels turn at a rate of 300 revolutions per minute. Remember, that is a rate, not your angular speed. So I'm going to put here 300 revolutions per minute. Okay, number 1, find the angular speed of the wheels in radians per minute. Well, you always use the rate to help you find the radians. So A will be, start with your rate, 300 revolutions per minute. And I'm going to change it, and I'm going to say 1 revolution is 2 pi. Okay, always use the pi in radians because that's what you're asked for here. So this will cancel with this. And then you're left with 600 pi radians per minute. Okay, so that's your answer for part A. This is the exact value, and we're going to go ahead and round to the nearest whole number. So here I'm going to use and say that is approximately, and I'm just going to plug this into the calculator. Let's do 600 pi. Okay, that's going to be approximately 1,885. Approximately 1,885 radians per minute, which is exactly the same unit that you have up here. Okay, for part B, it says find the speed, that means velocity, of the cyclist in miles per hour. C is equal to angular speed times R. Angular speed is going to be 1885 radians per minute times 12 inches. Okay, now let's make sure up here it says it wants it in miles per hour. This is inches per minute. So we're going to have to use dimensional analysis. When I do that, I like to go ahead and put everything in fraction form, especially our units. So I'm going to go ahead and start by changing minutes to hours. Minutes to hours. We know that 60 minutes is equal to 1 hour. So here I can see if the minutes is in the denominator, I put minutes in the numerator so they cancel out. Now I'm going to change inches to miles. So I'm going to say 12 inches equals 1 foot. Now what happens here is that changes and cancels out all of that with all of that. Use this information to help you with the rest of it. 5,280 feet is equal to 1 mile. Okay, the feet cancel out, so now if you look across, you're only left with miles in the numerator. Well, radians times miles, but the radians don't need to be there. And then the denominator, you're left with hours. So now you have miles per hour. Let's go ahead and put that. Let's go ahead and put that in the calculator. So I'm going to start with 1885 times, and I canceled this out with this one, so I'm going to times it by 60, and then I'm going to divide everything by the 5280. So 5280. Okay. When I press enter, I get 21.4. So this is going to be approximately 21.4 miles per hour. Okay, miles per hour. All right, number 3. Number 3 says a Ferris wheel at a carnival has a radius. So let's start with the radius is equal to 33 feet. Suppose it turns at a rate of 2 revolutions per minute. So let's go ahead and do that. Rate is equal to 2 revolutions per minute. Okay, find the angular speed. So it's just like what we did above. We're going to start with A, and we're going to start with our rate, 2 revolutions per minute. And now we're going to say 1 revolution is equal to 2 pi. Remember, it says radian, so you need to use 2 pi and not 360 degrees. Our revolutions will cancel out, and I'm left with 4 pi radians per minute. Okay, that will be approximately 4 pi 12.6 radians per minute. If I go back, it says actually on this problem, we're rounding to the nearest whole number. So 12.6 radians per minute is going to be equal to 13 radians per minute if we're going into a whole number. Okay. Part B says find the linear speed of the passenger in feet per minute. Okay. So now what we're going to do is we're going to go back to that equation, and we're going to use the same one. Velocity is equal to r times angular speed. We have our angular speed here. We have our r here. So v equals angular speed times r, and let's just substitute this in. I'm going to go ahead and use the values that were given in the previous answer. But because I don't want to do intermediate computations, I'm going to be using the exact value here. I suggest that that's what you do on your homework, because this one can be a little bit picky if it's asking you for exact answers. Okay, so we're going to go ahead and say angular speed is 4 pi radian per minute times 33 feet. Okay. It is in feet per minute. Here I have feet per minute. So then I can just take my value that I had before, which is here, and times the 33. Okay. So now I get 414.7. 414.7, and this is feet per minute. But then again, it says to the nearest whole number. So I'm going to round this up and say it's 415 feet per minute. Okay. And then that'll give you the answer to that particular section. Okay, let's go ahead and go on to problem number 4. Okay. Problem number 4, yep, I'm going to do this one too, separate from what I have originally. I might even upload these copies more than the other ones because I think it's a little bit clearer. All right, so it says a ceiling fan has 19-inch blades. So that means R is equal to 19 inches, okay? And suppose that the linear speed, so that's V, is going to be 8 feet per second, okay? Find A, find the angular speed. So we're looking for A, we're looking for W. So we're going to use V equals angular speed times R. We're given this as 8 feet per second. Okay, is equal to angular speed times 19 inches. Now, this is not a bad formula, but you can see that your feet and your inches are 2 different units. So you need to be careful on this part. I'm going to go ahead and divide everything by 19 inches, first of all, so I can get it to look like this. Okay, and now I'm going to rewrite, and I'm going to go up a little bit higher so we have more space to work. So I'm going to say angular speed is equal to 8 feet per second. Notice what I'm doing is changing this into a fraction type form. Okay, so I'm going to go ahead and change this to make it look like this over here. This is 1 over 19 inches. And then notice the feet and the inches don't cancel out. So I'm going to go ahead and change this from 12 inches to 1 foot. Now inches cancel out and now feet cancel out. Okay, but notice it says here it wants it in radians per minute, and now we have seconds in the denominator. So I need to change that and get 60 seconds. So my seconds cancel out is equal to 1 minute. Okay, there we go. All right, use the calculator. It's asking us to round to the nearest whole number. So I'm going to do 8. I'm going to do 8 times 12 times 60 divided by 19. There I go. I have 303. If I'm rounding to the nearest whole number, I'm going to say the angular speed is 303 radians per minute. Okay, that's part A. For part B, it says find the number of rotation it makes per minute. So remember, when you're going from angular speed to rotations per minute, it's a number of turns. So I'm going to start with my angular speed, 303 radians per minute, and I'm going to change that to revolutions per minute. So 2 pi radians is equal to 1 rotation. So these radians will cancel, and I'm going to divide by 2 pi. Again, you have to remember anytime it's in the denominator, you need to put parentheses around it. So I'm going to start with a 303 divided by 2 pi. Otherwise, order of operations will give you a different answer. Here you have round to the nearest whole number. You would have 48 revolutions, and that should be a squiggly line, 48 revolutions per minute. Okay, and that's the answer for that second part. So in the next section, I'm going to start by finding the terminal point on the unit circle denoted by this central angle, 11 pi over 6. Use exact values. So anytime you're doing this, you definitely want to use the exact values and not any kind of approximations. It will be counted wrong. You won't even get partial credit. So be careful about that. Here's my unit circle, 11 pi over 6. All I'm doing is finding the values that are associated with that point. So here, square root of 3 over 2, negative 1/2. There you go. Okay. For the next part, it says find the exact values. Cosine 5 pi over 4. Here's 5 pi over 4. Cosine is in the same thing as your x value, so you're going to take your x, and that's the answer for that one. Okay. Find the exact value. Cosine of 90 degrees. Here's 90 degrees, cosine's your x, so your answer would be 0. Try using your unit circle for this. Don't try and use your calculator, even though it is good for a check. You don't want to become, you don't want to 100% rely on that calculator. Okay. Okay, so the next part is going to be in this section. It's asking us to use these 2 points and find the exact values of these 3 trig functions. We're going to start with secant. Remember, secant is the reciprocal of cosine. So all I'm going to do is get the cosine value here and essentially flip it. So it'll be 2 over the square root of 3. Remember, you don't want to have radicals in the denominator, so I have to rationalize it, and then you get your final answer, which is going to look like this. Okay. The next one will be cotangent. Cotangent you can think of as cosine over sine or x over y. X is going to be just the numerator part because remember the denominators will cancel out. So I'm looking at the square root of 3 divided by negative 1, or in other words, simplified negative square root of 3. Sine, that's just our y value, and it's already listed as negative 1/2, and you're done. Okay, the next section here says find the exact values and state undefined if it is appropriate. So let's start with the first one. Tangent of negative 7 pi over 4. This is not a standard angle. So remember, you're going to have to add 2 pi, or what I ended up doing here was I found the common denominator, and 8 over 4 is the same thing as 2 pi. So I get tangent of pi over 4. Well, let's go back and use our unit circle. Here's pi over 4. Tangent is y over x, or square root of 2 over square root of 2, which is the same thing as 1. Okay. For cosecant, again, I'm changing this back into a standard angle, which is the same thing as I did here, exact same angles, so it's going to be pi over 4. And then remember, cosecant is the reciprocal of sine. So let's go to sine, which is right here, and we're flipping it. So it'll be 2 over the square root of 2, but by the time we simplify, you're going to get the square root of 2. Okay. Finally, we have cosecant of 180 degrees. We're going to go to cosecant here. Cosecant is the reciprocal of sine. So here sine is 0 over 1. So if I were to flip it, I would get 1 over 0. Anything with a 0 in the denominator is undefined. Okay. Here's the next section. Here it says find the exact values. State undefined if necessary. Okay, here I'm showing the work again. I'm showing that this is not a standard angle. I have to subtract 2 pi. When I get that, I get cosine of 5 pi over 6. And then again, go to the unit circle, 5 pi over 6 here. Cosine is your x value, which is the negative square root of 3 over 2. Okay. For negative 600, you're going to add 360 until you get a number between 0 and 360 degrees. Here I found that the coterminal angle, or the standard angle of negative 600 is 120 degrees. So I'm going to go to 120, which is here. And then I'm going to look at this one, which is cosecant. Cosecant is the reciprocal of sine, which is this one right here. So I'm going to have 2 divided by the square root of 3, but then by the time I rationalize it, this is what it'll look like. Okay. On this one, it's going to be cotangent of negative 2 pi. You're going to add 2 pi, so it's saying cotangent of 0. Cotangent is going to be your x over your y. So we have 1 over 0, which is undefined. Anytime you have a 0 in the denominator, it is undefined. Okay, next problem. Okay, here we're going to be evaluating some more. It's giving us one angle and it's asking us to find the exact value. So you don't want to use your calculator for this. We're going to be using the unit circle. Whenever you have a 2 out here, that 2 is not the same thing as it being inside the theta. So I'm going to leave the 2 on the outside, and I'm going to replace my theta with the theta that I'm given here. Okay, so then I can evaluate what is cosine of 4 pi over 3. Going back to our unit circle, you're just going to look for 4 pi over 3. And we're looking at cosine, which is negative 1/2. So what I did here was I left the 2 here, evaluate cosine of 4 pi over 3, and found that to be a negative 1/2. Multiply these two, you get a negative 1. Okay. Notice on this one, it's different because now you have a square, but you're not squaring the angle. You're specifically squaring the ratio of cosine theta. So when I'm doing this, I'm going to first evaluate what is cosine 4 pi over 3. Well, we did that in the previous one, and we found cosine of 4 pi over 3 to be negative 1/2. So my negative 1/2 is here, and then I square the entire thing. So negative times negative, positive. 1 times 1 is 1, and 2 times 2 is 4. So in this problem, your answer will be 1/4. Okay, looking at part C, now you can see that you're taking theta and dividing it by 2. So that's what we're going to do first. Theta is still 4 pi over 3, and you're going to divide it by 2. When you use your calculator, you can actually just use your numbers, just like what we've been doing before, and it will do these complex fractions for you. So I'm going to start my fraction by saying 4 divided by 3. That's one individual fraction, and then I divide the entire thing by 2. Once I do that, I can convert that back to a proper fraction, which is 2/3. There's my 2/3 pi. Then go back to the unit circle and then say, hey, cosine of 2 pi over 3 is negative 1/2. So then you have your answer there. Okay. Here are your odd and even functions. Remember, the only ones that are even are going to be your cosine and your secant. So those are the only ones that are going to be even. That means that whatever is in here is going to be equivalent without the negative. Whatever is in here is equivalent without the negative. For the other trig functions like tangent and sine, those are going to be odd functions. So whenever you have a negative inside, you're essentially going to be able to take that negative outside, but keep the number the same. Okay, same thing here. Take the negative on the outside, keep the number the same. Okay, last problem. This is going to be evaluating your sine functions that model a real world situation. So on these problems, you're given a formula. Use that formula, and then I use the variables that were given, negative 20 meters, b, 3 pi over 5 radians per second, t was 2 seconds. Notice I canceled out the seconds because you have one in the numerator and one in the denominator. Those cancel each other out. Plus c, which is 27. Okay. So I multiply all these together, I get 3 times 2 is 6 pi over 5. Everything else comes down. Now, cosine of 6 pi over 5 is not here on the unit circle. So when it's not on the unit circle, all you have to do is plug that directly into the calculator, and then you get your answer. Here it says round to the nearest hundredths. So I wrote down 3 decimal places. You can see that this is a 0, which means the 8 stays. And then don't forget your units. This doesn't have units here, but the meters is here, so meters plus meters is going to equal a meters. So this is going to be your answer. I didn't do it in the calculator. Make sure that you're in radian mode since you're using radians. All right, so that concludes the 4.1 worksheet. Hopefully, I know I didn't work every single problem out myself. I did that for the sake of time. The ones that I felt like needed more explanation or a better explanation than what is given to you on the current worksheets are now provided. All right, let me know if you have any questions.